So standard form where it's ax plus by equals c. Your a and b are constants, okay? You will never see fractions primarily through this. You won't see fractions and or negative numbers. Your a value, you will notice, is always positive, okay? So to find your x-intercepts, okay, how do we do that? Lucy? Okay. Oh. Okay. All right. Anybody else? Yeah. Okay, x-intercept is your number, comma 0. Okay, so again, you could get it into y equals mx plus b if you wanted to, but for x-intercepts, you would have to solve for x, right? So we substitute 0 in for y, so 3x equals 30, so 3x equals 30, x equals 10. So your x-intercept, you could either write it two ways, x equals 10, but a lot of this we're going to see in this notation, okay, as a point. Okay, as a point, this is where I want you to become familiar with it. Okay, even though both are correct, I want to see this. Okay, 10, 0, your x-intercept. Now your y-intercept, if we substituted, say, y equals 0, in order to find the y-intercept, what do we have to do? X equal to 0. 0 minus 5y is 30. Y equals negative 6. So, again, if you had y equals negative 6, true notation, 0, negative 6. You would get the same thing if you went into y equals mx plus b. Okay? The b value is your y-intercept. All right? Any questions? Answer? Good. Anything else on the first page? I mean second page, sorry. No? Okay. And then the last page. Yeah. Yep. Any questions on the last page? Yeah, Jason. Yeah. So this would be new. Okay. This notation is you first are given inequality notation. Interval notation is where we are going to spend a lot of our time. Okay. Interval notation is we're going to use for domain, range, intervals of continuity, which will be new, as well as characteristics of graphs. So interval notation is where we're going to be. So if we see 8 is less than or equal to x, which is less than 16, okay? Say if I have 8 and 16, and I'll do the circles above, okay? If you see the x in between, this is a compound inequality, okay? It's a compound inequality where the graph falls in between 8 and 16. Okay, falls in between. So all the values, including 8 through 16, would be included in this graph, let's say. Okay, so how we write it in interval notation, if there's an equal to, okay, less than or equal to, you're going to have a bracket. Okay, so less than or equal to, you will have a bracket. 8, comma, 16. Since there's no equal to, you will have a parenthesis. Okay. When we are using infinity, which you're going to see in the next one, number 12, infinity always has parentheses. Okay, so we have x is greater than 0. So if this is 0, okay, since it's greater than, am I going to have a closed or open circle? Open. Okay, so that's another thing. If it's not equal to, you will have an open circle. Now, where x is greater than 0, is that arrow going to be pointing to the left or to the right? Yeah, John. To the right. Okay. Where is it heading to? Where is it heading to? Yeah, Mike. Infinity. So since this is greater than, I'm going to have parenthesis 0, okay, and then infinity, okay, where it keeps going forever, right? One thing with interval notation and inequality notation has to be least to greatest. Least to greatest, same with set notation, which was above, okay? Interval and inequality, least to greatest, okay? Least to greatest, okay? And this next one, which will cover all of them, all right? We have x is less than -3. Is that going to be an open or closed circle? Should be open, okay? Where would that arrow be pointing? To the left, because it's less than, okay? Then we have 4, open or closed circle? Closed. Which direction? Okay. When you have them going in opposite directions, okay, your interval notation, we do one piece at a time. So, what would come first here? Where is this heading to? Negative infinity to -3. Would I have a bracket or a parenthesis? Parenthesis because it's not equal to. Now, since it's opposite, you put this little u there, which means union, which is or. Okay. Then we have 4 to infinity. But around the 4, what am I going to have? Bracket, infinity. Okay. So those are all the different notations. Number 16, if it's just a point, then it would be 3. Yeah. So you only have the or. Yep. So you're going to see this a lot in terms of the U for increasing, decreasing when we get to the graphs. Okay, so the U represents or where it's happening again, where the domain picks up. Okay, any other questions on this? Okay, we're going to see a lot of interval notation, so if you weren't really sure what to do, don't worry. Okay, when you get to the graphs, visually, it's going to look a little different. Okay. All right, so if you turn to this next page, okay, you guys don't have the notes yet, so I'll give those to you. When you get your notes, 1 through 5, I want you to work with your partner. This is SAT and PSAT questions taken right from the test, okay? It has to do a lot with function notation as well as linear functions, okay? I'm going to give you about 5 to 8 minutes, okay? Yeah. D, how do we get it? What are some things you could tell from the chart? Yeah, Mike. Well, it is linear. Good. Okay, so it's linear. What are some other things? Yeah.
It's going up in the x, and then no 2 in the y, and then 1 in the x, and then you're starting at.
So your t values are increasing by 1. Okay, think of it as an arithmetic sequence. Okay. This, however, 0, -1, as a point would be what? Your y-intercept. Okay, this is your y-intercept. And if you're increasing by 2 every time, your rate of change, which we just did, which is also your slope, is 2. Okay, so if you know, all right, that your initial term, okay, a0 is -1, if we did it this way, it's 2 times n. Or if you used arithmetic sequences, our first term is 1 plus n-1 times 2, you will get the same answer. Okay? This would be D. All right? So it's a linear function. This is very similar to number 1 on the post-summative as well. Okay? So that's where they go hand in hand. The wording, half the time with PSATs and SATs, the wording of questions confuse you. 100%. I get that, I know that, and I understand it. Okay? So when we're looking at it, go through what you know already. All right? Then you interpret the question. Okay? Because the question itself can be confusing. That's half the time, which makes PSATs and SATs difficult. All right? So if we look at number 2, what do we get? Jason. D. Good. Okay. So we do f of 2 first. What did we get for f of 2? -1. Then we do f of 5, which is? Okay. Then we do f of 2 is 5, which gives you the 4. Excellent. Okay. Number 3, I don't think anyone got right. Okay, looking around. Yeah, Mia, you got it? It is E. Good. I didn't come over to you guys, but good job. How'd you get it?
It says f of a plus b, not like f of a plus f of b.
Right. Good. So the notation, definitely. So we know, excellent, 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 excellent. F of A equals 9. So 4A minus 3 equals 9. What did A equal? 3. Okay, that's that. Keep that in mind. Now we do B minus 3 equals 5. What did B equal? 2. Okay. Now, f of A plus B is f of 3 plus 2. We have to now find f of 5, which is 17. Excellent. Yeah, awesome job. Yeah. That's what you're trying to find. You're answering that question. What is f of A plus B? So we found the value of A, right? We found the value of B. We have to add those two together. We get 5, and now we have to evaluate f of 5. It's okay. It's okay. It's multi-step here, okay? And this notation, f of A and f of B, throws people off no matter what. They're like, well, I have f of x. What does that mean? You're just replacing the x with the A or B. Okay, excellent job. Number 4, another multi-step, f of -2.5 equals k. Well, k in this case represents what? Y. So, f of -2.5, we need to find that y value. So you look at the graph, -2.5 is here. What is my y value? 1. So we know this is equal to k. All right? So now we do f of 2 times 1. F of 2, which means x equals 2. What is my y? 0. Okay, for function notation, okay, that's what's throwing us off. Okay, K is the same thing as Y in this case. Okay, F of some number, this some number is equal to X. Okay, when X equals negative 2.5, what is our Y value? And in this case, Y is represented by K. Okay, then you take that value, you multiply by what's given, you substitute it in for K. So F of 2, look at the graph, Y equals 0. Okay. Now we have H of X equals 3X plus 5, and H of A equals 27. Then what is the value of A? Okay, yeah. 7 1/3, how'd you set it up? Okay, I'm just going to change it because it's H of A. So 3A plus 5 equals 27. Okay, so when you see either H of X equals some number, that means Y equals that number. Okay, so now we solve. If you had 22 over 3 or 7 1/3, you're correct. Okay, any questions? Okay, again, the way questions are asked definitely can be confusing. Multiple steps, okay, multiple steps. And we will be incorporating a little bit of these as we go along, okay? If you look at the next page, for independent versus dependent on the next page, possibly have heard these terms before, okay, and we're going to do it as a group. What, either one, independent or dependent, what do we got? How can you define it? Define it. What does independent represent? What does dependent represent? Yeah.
Is it independent like the variable that like you can change?
Yeah.
I don't know if that's like, yeah, like sorry.
You're okay. So if you said it correct, it's a variable you could control or change, right? So in terms of our variables, what would that be represented as? X. Good. So X is your independent variable. A variable that can be changed or controlled in order to measure a dependent variable. Okay. So what would the dependent variable be? Yeah. Good. So we have our Y value, okay? It's a variable that is being measured. Okay, so it's the result of your independent variable. So if we look here at this first graph, all right, we have number of pages, total cost in dollars. Which one is the independent variable? Yeah. Good. Number of pages. Therefore, what would be the dependent variable? The total cost. Good. Again, we're talking of money. All right, so with your partner, I'll give you about 2 minutes. B, C, and D. Go ahead. Through this, for B, what would be my independent variable? Julia? Weeks. Good. What is my dependent variable? Go ahead. Money saved. Good. Excellent. Now let's look at C. What is my independent variable? Go ahead. Good. The room. What is my dependent? Go ahead. Oh, cost. Good. Cost. Excellent. All right. Now D. What's our independent variable? Go ahead, Jason. Questions. Correctly. And then what's the dependent? Luz? Good. Excellent. So if you kind of looked at all of this, the dependent is your cost. A lot of the time when we get to word problems as well, you're going to see the dependent variable be your cost measurement depending on how your x changes. Okay? So now, looking at our domain and range, okay, scan the graph always from left to right, okay, always, left to right. Look for any times an x value is not included, meaning an open circle, or something called a gap or an asymptote, which is, we'll discuss a little bit later. If x values are not included, then you have to start a new interval, okay? That's where that u comes in, okay? If for the range, you're scanning the graph down to up, what's your lowest y value to your highest y value, and again, you're looking for open circles, gaps, asymptotes on the graph if there are any, and then you have to start a new interval if there is, okay? Now, for domain and range, if a value is included, we use a bracket, okay? If a value is not included, meaning an open circle, infinity, possibly break in the graph we're looking at, you're going to use parentheses, okay? So, on yours, I definitely changed it, added the arrows here, okay? If we look at number 1, domain, you're reading this from left to right, okay? Domain are your x values. What would my domain be of this function? From left to right, you have arrows going in either direction. Yeah, Anton. Good. Negative infinity to infinity. Since the arrows are going down, we don't know if it's continuing and going out, staying where it is. So since we have these arrows going from negative infinity to infinity of the x. How about the range? We now do the y's. Bottom to top. What is the lowest y value that will be included? Yeah. Okay. Negative infinity to 4. Now, negative infinity is going to have what? Parentheses. However, 4 is going to have what? A bracket. Excellent. Everyone okay? Yes, no? No, yes? You're going to see as we go through. So here, at the top of your graphs, these are now points. Okay? Looking at your domain, what's the lowest, the smallest x value being used? -3. And if we go from -3 and scan all the way across, what's the largest x value being used? 3. Both of those are going to have what? Brackets. Good. Now we look at the range. Bottom to top. What is the smallest y value being used? Julia? 0. What is the largest? 9. Both of those are going to have? Okay. Let's look at number 3. Okay. Looking at our domain. Okay. Looking at our domain. What would we have? Julia? Be careful, there is a point. It might look like an arrow, but this is a point. Okay. Yep. Good. Okay. Domain, left to right. We have -5 to 1. Okay. Why didn't I continue or Julia continue from -5 to 5? Yeah. there's a break in the graph. So the numbers between 1 and 2 are not being used. So that's where we have to include union. However, to continue, 2 to 5, 2 is going to have what around it? Parentheses, and then 5 is going to have bracket. Okay, -5 has a bracket because it's a closed circle. 1 has a bracket because it's a closed circle. We have to include the or because there's a break in the graph, and then the domain continues. Okay, let's look at the range. Bottom to top. Scan all the way through. It's okay, go ahead.
-2 to 1.
Careful. Look all the way across, too. Is 1 being used? We go to bottom, right? Scan, scan, scan. And you were stopping here, right?
Yeah.
But looking, if I keep going up, is it being included?
Oh, yeah.
Okay. So that's one thing I'm glad you actually said that, because that's the mistakes that happen all the time, right? I'm glad you actually pointed that out. That's good. Because here, just because there's a break, it's still included over here. Okay, the y values are being included. So we have the range of -2 to 4 with a bracket. Okay, so it still continues on the y values because it is being used. If there was a circle here, an open circle right here, then you would definitely use the u. Okay, make sense? All right, you guys are going to give 4 and 5 a try on your own. Go ahead. Okay, let's go through it. For number 4, what would our domain be? Julia? And 6 has what? Excellent. -infinity to 6. How many of you did get that? Okay, so looking at it, I put a little diagram on the board. When you're looking from left to right, if you see arrows going in this direction, okay, here or down like we saw before, we're assuming it's heading to -infinity. We only see what we see. So if we see these arrows, as you read it left to right, it's from -infinity, then it stops at 6. We have to have a parenthesis. Okay, how about our range? Jason? Careful, careful. What's your smallest y value being used? Go from bottom to top. -2. Okay, and this is, we don't know if it's going up, it could increase. So where is that arrow heading? Infinity. Good. Open circle. Okay, so we're going to stop right there. When we get back from lunch, we'll finish up 5 and then get to continuity. Number 5, okay, looking at this right now, for number 5, what do we say for the domain? Luce, go ahead.
Actually, now I don't know about it.
Okay, what do you think?
-9 to 30.
Yeah, good. -9 to infinity. Excellent. So, x values, right? -9. Okay, looking at all the x values. And what am I going to have around -9? For the parentheses, okay? -9, if I keep going, at -2, I'm still included here, right? I keep going until this arrow is heading to positive infinity. Yeah.
But, like, isn't there a break?
But I want you to look at all the, there is a break. It's going to change the range. Okay? So I want you to look at all the x values in this problem. Okay? So -9, -8, blah, blah, blah. -2, even though there's a break, -2 is still part of that domain. Then -1, 0, all the way to infinity. Okay? It's still being used. Okay? And we have parentheses around infinity. Now looking at the range, okay, now looking at the range, be careful. What do we think? Yeah.
I said -2. I'll put it in parentheses. -2 is 0.
Okay.
I said U brackets 1 7 bracket.
Okay. All right. Anybody else? Where is this heading? Arrow keeps going, right? Okay. We keep going. All right. So what's the lowest y value being used? Negative infinity. Okay. If we take that arrow all the way up, what's the highest y value being used? 1, 2, 3, 4, 5, 6, 7. 7. Okay. The arrows, it seems like, are the most confusing, just by looking at your facial expressions from this first one to now this one. Okay. In terms of arrows, yeah, Jason.
Why is
-9 is an open circle here. Okay. 7 is enclosed point. Yep. Always. Always. Because you can never touch it. You're approaching it. You're never getting there. Okay? Both positive and negative infinity. All right? So infinity, always parentheses. Positive and negative infinity, always with parentheses. Okay? If there is a hole like this, also parentheses. Okay? Solid hole or solid circle will be a bracket. All right? And as you're going through this, even use your pencil. Okay? Looking at your x's this way. Okay? Going across to make sure every x value is being used. And then your y is bottom to top. Okay? We're going to see a lot of domain and range. Okay? I just want to, you could include this probably at the bottom or on the side somewhere. If you have a graph, and we're just going to look at domain right now. Okay, that is like this. Okay, if you have a graph like this, what would our domain be? Yeah. Negative infinity to infinity. Okay, even though the arrows are pointing up, if we're looking left to right, it's including every x value. Okay, if I have another graph like this, what would our domain be? Okay, if I have another graph like this, what would my domain be? Okay, if I have graph like this, negative infinity to infinity. Okay, so these are all examples, especially with the arrows, and there's hundreds more, thousands even, okay, with the arrows where negative infinity and infinity will be your domain. Okay, the range obviously will change. If this was, say, -4, what would my range be? And -4 will have what? Good. Okay. What would my range be here? Good. Negative infinity to infinity. How about my range here? Good. And if I had this graph, what would my range be? And 2 has? Yeah. Excellent. Okay. If you had back here with the breaks in the graph. Okay? Again, go left to right. Even if it's open circle here, if you look to see there's another point, it's still going. Okay? Same with this arrow. Remember, it keeps going down. That's what the arrow means. Okay? Yep.
For domain, I know it's left to right, but for range, is it
Bottom to top.
bottom to top?
Bottom to top. Yep. Okay. So, this new idea. Okay, this new idea, which is new for you guys. Okay? What do you think it means for a graph to be continuous? What do you think it means? Or if you could give me an example of a graph that is continuous. Celia? Okay. Negative infinity to infinity. What would be a graph that would resemble that? Any idea? Yeah, Isabel. Good. So continuous would be negative infinity to infinity. Both ends have arrows. Okay, as an example. Yeah. Question. Linear, right? Linear functions. Good. Okay. So we're going to determine now, are the graphs continuous or discontinuous? So this first graph. Why?
Because there's an arrow. At least on the paper, there's an arrow at the top.
Okay.
And there's not one at the bottom, so that means that it only goes up.
Okay. And if there was both arrows here, right? What would you guys then say? Careful. What's the difference between, okay? We're going to show the two. This is discontinuous. Okay. Now, what would this one be? Continuous. Okay. Now, I want you to take your pencil, okay, or whatever you're writing with, and just trace this. Okay. Anytime you see a hole or a break, lift up your pencil. Okay. So, I'm going here, right? Oh, there's a hole. Lift my pencil and keep going. Okay. Now go to the next one. Follow the graph. See if you lift your pencil at all. Did you? No. Therefore, it's continuous. Okay? Discontinuous means if you look at this last graph here, you have to pick up your pencil to move it again. Okay? So here, if I'm following, I have a hole and a break. So that means I have to pick up my pencil and move it in order to continue. So here is also discontinuous. Okay? Where linear functions, unless there's not a hole, if they're a straight line, you're not moving your pencil at all. Therefore, it's continuous. These functions here, moving my pencil, not taking it up. Okay? It's continuous. However, if there's a break or a hole, I have to move my pencil, therefore it's discontinuous. Does that make sense? Like a break in the graph. Okay? So now, the domain interval includes all values of x that are included in the function. The continuity interval includes all intervals of x where you can graph the function without lifting your pencil, okay, over the domain of the function. Domain is your x values. The interval of continuity always uses parentheses. Always. Okay? Interval of continuity always uses parentheses. Yep. Mhm. Mhm. The arrows won't. If the arrows are pointing up, that's where it's heading. Yep. If the arrows are pointing up, that's where it's going. Okay. Great question. So at each number that causes a disruption, meaning you're lifting up your pencil, you must start a new interval. That's where the U comes in. Okay? So there's a difference. We're relating continuity to domain. With piecewise functions, which are these guys here, okay, graphs that are defined on multiple intervals of x will often break the rules. Okay? So if we look at A here, okay? If we look at A, x values where the graph is discontinuous would be where? Yeah, it's 2, when x equals 2, okay? How about for B? Where is it discontinuous, where you have to lift up your pencil? What x values? Those? 1 and 2. Good. Excellent. Okay. How about C? Yeah. 1. Everyone okay and see that? Are you okay? So all we did just now is know where the x values are discontinuous, where there's a hole or where there's a break in the graph. Okay? So now we're going to write intervals of continuity. Okay? So here just include arrows at the following. All right. So now, if we're looking at A, what can we say? How can we figure out the interval of continuity? What's the smallest x value? We're looking at domain only. So we're looking at our x values. Yeah. Negative infinity, good. Okay. So from negative infinity to where? Yeah. 2. And then, since I have to continue, I'm going to put a u. And how do I continue that? Yeah. 2 to infinity. Okay. So right here shows the hole in the graph, where you have negative infinity to 2, union 2 to infinity. Okay. So let's look at the second one. Okay, start left to right. What's the smallest x value? Yep. Positive or negative? Uh-huh. Yep. Be careful. Okay, hold on. We're missing something. We go negative infinity to 1. Then what's this interval? 1 to 2. Then where? Yep. Okay, we have 3 intervals because you have one graph here, one piece, you have a break, another piece, break, and the third piece. Okay? How about the next one for C? Do your first line, the first line on the left. Go ahead. Careful. X values. Yep. Yep. Perfect. Good. Okay. That's intervals of continuity. Always parentheses. The U is when you continue it. Okay. The U is when you continue it. If there's a separate interval. When there's a break or a, yep, hole. Never. Intervals of continuity is always parentheses. Always. Domain has the brackets. Okay. We're going to try some practice. Okay. You're going to see a difference now. Okay. Looking at, there might be the same similarities, there might be differences. Okay. So, looking at number 1. Okay. What is the domain? And those are points at the top. Yeah. -4 to where? Okay, -4 to 4. And what am I going to have? Brackets. Okay. X values where the graph is discontinuous. None. Good. So what would the interval of continuity be? It could be the same as what the domain is. It's still your X values. Yeah. Good. -4, 4 with parentheses. It could be the same. Okay. Sometimes your domain in intervals of continuity could be -infinity to infinity. Yeah. Mm-hmm. Always the interval is you're looking at pieces of the graph. Okay. As opposed to the domain is looking at the graph as a whole. So domain will have either brackets or parentheses. Interval of continuity, no matter what, will always have parentheses. Always. Yeah. Why? The 4 is here. Okay. Yep. -4 to 4. And for evaluating, f of 0 would be what? -4. This means when x equals 0. How about f of x equals equals +1? So what do we have to find? No one knows? Yeah. How'd you get it? What does this notation mean? Okay, it's okay. What does that notation mean? F of x equals 1. Yep.
It would be like 1 when 1 is 1.
F of x means the same as y. So y equals 1. Therefore, what is x? So when y equals 1, so it's here and here in your graph. There's 2. Okay? You guys could make it clearer on your paper. Here's when y equals 1. You want to know where x is. Okay? So anytime it's an approximation, little squiggly line, okay? Some of you might say -2.2 and 2.2. Some of you might say 2.5. And again, it's approximation. Yep.
You do the plus or minus.
You could. Yep. You could. I haven't heard from half of you today. Number 2. What's our domain? Yep. Careful. An estimate is okay. An estimate is okay. Good. Okay. So -infinity to -0.5, would that have a parenthesis or a bracket? Parenthesis. And then what do I have to include again? U. And then? Good. Okay. X values where the graph is discontinuous. Yep. Good. X equals -0.5 or -1/2. Good. Now how about the interval of continuity? Yeah. Okay, how would I write the interval though? You're right. Is 1/2 of it. Okay. Intervals of continuity is where you're breaking it up. Yeah. So is it the same? Yeah, those guys are the same. Okay, these two are the same, which is okay. Okay, as opposed to the first one, they were different just based off the brackets versus parentheses. Here they are the same because we have a whole at -1, half. Okay. All right, so f of -1/2. Yeah, careful. Careful. There's an open circle, right?
So
Would there be a value of y if there's an open circle? No. Okay. This would be undefined. Undefined because there's a hole. Okay. If it was a closed circle, then yes. Okay. Or if it was a straight line, continuous line. Here, there's an open circle, so there's no y value for that. Okay. How about f of x equals 0? Yep. X equals 0. Do we agree? Yeah, we do. Good. X equals -1. Okay, where y is 0. All right. Questions? Yeah. Go ahead. Question?
Me?
Yeah.
So wait, for the evaluating, you just do it by looking at the graph?
Yeah. Because there's no equation. We don't have an equation. So you're looking to see, when you see this notation, x is equal to 1/2, you're trying to find y. Here, when y is equal to 0, what is x? Okay? Yep.
Wait, so for the f of negative half, would it be, wait, I don't get why it's undefined though, because doesn't that mean when x is, or when y is, oh wait,
When x is -1/2, what is y? There's a circle there. So that's why we have the parentheses here, right? If we had a bracket, it would be included, okay? Just like if I go up here, okay? If I wanted to see f of -2, I have a solid line there, so it would be 0, right? If I wanted to see when f of x equals -4, my x value would be 0, okay? If I have the whole, like I see here, say if I wanted to know, and this is a prime example, f of 1, what would you say? F of 1, what would you say? How many of you say 4 for f of 1? Nope. F of 1, it would be 2. 4 would be, it wouldn't happen at 4, okay? You can't even say for f of 1, it looks like 2 values, but if I had 2 values there, it wouldn't be a function, right? Okay, so here is a prime example. When I'm looking for f of 1, I look to see f of 1, I have 2. It would not be 4 because I have an open circle. Okay, if I wanted to see f of 2, which one would you say? 1. You would not say 4. Okay, so closed circle means it's included. Open circle means it's not. However, we still need it to represent our domain and interval of continuity. That's why for the domain we include the parentheses, because it's not included in the domain. Everything else is, if I wanted to find -1, -2, I have a corresponding y value. But at -1/2, I do not. At 0, I have a corresponding y value. But at -1/2, I do not. Okay, that's what it means. Okay, yep.
So the graph that above on the last page, have like a dot under it.
Yep.
Is that still a function?
It's still a function.
How would I like what?
If it wouldn't be a function, because I have an x value going to two outputs, which you cannot have. Okay? That's when it means to not be a function. All right. What's my domain? Jot it down. Bless you. Okay. What's my domain? Isabel, go ahead. Careful. Domain. Look at the whole big picture. Whole big picture. Yep. Negative 4, 4. Both of them are going to have what? Brackets. Negative 4, 4. Okay. Where is the graph discontinuous? Where do you have to lift your pencil? Yep. 3. Okay. Now, interval of continuity is looking at the pieces. Okay. So this is your first piece. From where to where? In parentheses only. The first piece. Julia? Perfect. Good. Okay. Domains looking big picture. Intervals of continuity, splitting it into pieces. Okay, sometimes they may be the same. Now we're looking at f of 1. What would it be? F of 1. F of 1. 2. Good. Okay. F of 3. Negative 2. Here is f of 3. Open circle was here. This is a solid circle. So the value is negative 2. Okay? And f of x equals negative 2. What do we have for y? So negative 2. Okay. Is the green. Right? So negative 2, we have this value here, which is, let's say, approximately negative 3.5. Okay. And where else? Yeah. Go ahead. 3 and 4. So, hold on, before you write anything down. How would I write it, though? You guys. How would I write it? 3 and 4 is correct, but is there other stuff in between? Yeah, Isabel. Okay, so we would include 3 to 4. Since it's a horizontal piece of a graph. Okay. Try number 4 on your own. And then this is it. And the graph is up here. That's a little bit clearer than you might have, possibly. All right, what would the domain be? Remember, the whole thing. Look at the whole thing. Jason. Okay, what would I have around it? Around both? Okay. Look at 8. Good. Negative 6, 8. Bracket around negative 6. Because it's a solid circle. Open circle, I have parentheses. How many of you did get that correct for domain? And space. Okay. If you're splitting it here, okay, that is the interval of continuity. Okay, domain is looking at the graph as a whole, the whole thing. Okay. Where is the graph discontinuous? Julia. Good. Okay. -2, and then we have 4 because there's no other there. Okay. Now interval of continuity is looking at the pieces. So how many pieces do we have here of a graph? 3. So we have 3 separate intervals. Okay. So what's my first interval? So this first line here, and no matter what, parentheses always. Go ahead, Luce.
-6.
Okay, hold on one second. That's that first one. Then we jump. Go ahead.
-2 to 4.
Good. And that's this one here. Then, excellent. So, if you guys notice, is my domain starting and ending included? Yeah, we're just breaking it up into pieces. That's what continuity means. All right, now we get into evaluating. V of -2 would be what? Isabel? Excellent. Good. Okay. V of 4. Oh, and what do you have? V of 4. -7. Good. Excellent. Yeah, -4. Good. Or would I agree with that? This looks different on this. Yeah. Good. Okay. How about V of H equals 3? So we're going to go with 3. And these are all probably approximations. What do we got, Mike? Yep. Okay, approximation. Some of you might say just 6, okay, because the graph is a little bit hard. -3, 2.5, possibly 6.5 or 6, depending on the graph. Yeah,
Wait, where's the -3?
right here.
Oh, okay.
Okay, in between it skips by 2s. Okay. All right, V of H equals 6. Okay, so 6 is here. Okay, so what do we have, roughly? And again, approximations. What's my first one? What did you guys say for this? Yeah. 4.5. Okay, then we have this one, like -1.9, 1.8. And then we have this guy here, about 2, approximately 2. Okay. Okay, so my main thing from today, understand the difference between the two? Probably this last one. We understand the difference between domain and interval and continuity? Yeah. Right, because it's an open circle. Yep, good. All right, you guys.